Stop hosting your critical applications on a single server. If that server crashes, your business goes offline. If your hacker gets in, they have your database passwords. We can do better. Hi everyone, I am Ismail Oyeleke. Today we are going to build a true enterprise-grade DB-tier web application on AWS. We are not just launching an EC2 instance, we are separating our infrastructure into 3 secure layers. First, we have the presentation layer for traffic, we have the logic layer for our application, and we have the data layer locked away in a private network. We're also going to use a custom VPC, auto-scaling, and application load balancer. And my favorite part, we're going to be using AWS Secrets Manager to completely eliminate hard-coded password. So without further ado, let's get building. First, we need a house for our infrastructure. So I'm going to create a VPC, a virtual private cloud. So on our console, we'll go to VPC and then we'll click on your VPCs on the left tab, and then we'll create a new VPC. Create a new VPC and more. Click on VPC and more. Then for the CIDR block, we leave it as it is. For the number of availabilities, we'll keep it at 2. The number of public and private subnets will also be 2. So we're going to go ahead and edit the CIDR block for the public and private subnet. We're going to be giving the public subnet 1 and 3. So the IP address for our public subnet in the different availability zones will be 1 and 3, and for the private subnet we'll give it 2 and 4. So /24 for that, and .0.4/24 for the second availability zone for our private subnet. So we have 2 public subnet and 2 private subnets now, as we can see, making 4 subnets available. So with that being done, the next thing is our NAT gateway. We will be creating the NAT gateway later in this video. We would not create it now. So for VPC endpoints, we don't really need it for this project, but I can turn it on, and then I might probably delete it later, but we won't be needing it for this project, and it is completely free to use. So additional tags, and let's go back and check everything again. For the name, we're going to give it my enterprise VPC. My enterprise VPC. Then we check for every other things as a precaution. We have the name, we have 2 availability zones, and we have the CIDR blocks customized already. For the NAT gateway, we'll be creating the NAT gateway later in the video. So we can now create our VPC. But before we do that, let's look at the preview of what the infrastructure is going to look like. So we have the VPC, which has it have 4 subnets, 2 in each availability zone, US East 1A and US East 1B. We have the route table created and the network connections created for us. So we'll be editing them later in the video. We are going to create VPC now. There's an error somewhere. The IP address are overlapping. So this is not supposed to be 20, it should be 24. So we're going to change that to 24. Please, the IP addresses should not be overlapping. Then we click on create VPC to create the VPC. We're going to wait for this VPC to get created. Then we're going to view the VPC. And now we can edit this, my enterprise VPC, as the name. So we can edit that. The next thing we're going to be doing is to view our subnet that we just created. So we click on subnets. We should have 4 new subnets for the VPC we created now. So we're going to refresh this. We're going to change their names. The first one, to this is going to be the private subnet 1. Please make sure it is in the US East 1A availability zone. So we're going to check that US East 1A, US East 1A. Then the next one for the private, the public subnet 1 should also be in the US East 1A, and we'll change the rest of the subnet US East 1B for the public subnet 2. It should be in US East 1B, US East 1B, And the last one is the private subnet 2. Should be in the US East 1B availability zone 2. US East 1B. So now we can filter it by the name of the VPC. So we filter by the name of the VPC we just created. VPC, and so these are the 4 subnets. We have 4 subnets for high availability to ensure that the application remains online even if a single server fails. The public subnet hosts the application load balancer and NAT gateway for connectivity, while the private subnet hosts the EC2 instances running the application. It also hosts the Amazon RDS database layer. Then we check out our internet gateway. It is already created during the VPC creation, and here it is. We have our internet gateway already. So the job of the internet gateway is to act as a bridge that will connect your subnet to the public internet. The next thing is to create our route tables. The route table were also created during the VPC creation. We just need to confirm the route and the subnet association. This route is correct, 0 to the internet gateway, and then the subnet association, as we can see, we have it to the public subnet 1 and 2. So this is the correct public subnet, public route table. So we are going to edit this to the public route table because it is the route table points to the internet gateway. Then we're going to create another new route table for the private route. We're going to call the private route table. I'm going to choose the VPC, enterprise VPC, our VPC. So we have to edit the route and also the subnet association for this. And to do this, we have to create a NAT gateway in the public subnet and use it in the private route table. So we'll be going to our NAT gateway. We'll navigate to the NAT gateway and create a NAT gateway. Create NAT gateway. We are going to name this my enterprise NAT gateway, NAT NAT, and then it's going to be zonal, and we're going to pick our public subnet 1. It has to be in the public subnet. Then we're going to allocate it an elastic IP and create the NAT gateway. So once we have the NAT gateway, we go back to our route table. We go back to our route table, the private route table. We'll click on the private route table. Then we can first edit the subnet association and add the 2 private subnet 1 and private subnet 2. Save association, and then we have to edit the route. So we'll scroll down, edit route, and we're going to add them from internet to the NAT gateway that we just created a while ago. So now we have the internet to the NAT gateway, and then we can come back to preview our VPC. And as we can see, we have 5 route table. We don't need 5 route table, we only need 2. So we can go back, and the remaining 2, I guess, are the VPC endpoints we created during the VPC. We don't need them, so I'm going to go back and delete them now. But as you can see, we have the private and the public route table. So let's go back to the endpoint here. I want to delete the endpoint. Delete endpoint. We won't be needing the endpoint. So go back to, and we can delete it here. The route table for the endpoint, we don't need them. So now we have just our public route table and our private route table. We can now go back to preview our VPC. And as we can see, now we have our public route table associated to the public subnet 1 and private subnet and public subnet 2. And also our private route table is associated with the private subnet 1 and the private subnet 2, which is what we want. And since everything seems to work fine now, we will go ahead and create the instance, our EC2 instance, which we are going to be using for the web tier layer for this application. So it is time to launch the application. I'm going to spin up an EC2 instance in the private subnet, but I'm not going to SSH into it and install software manually, but instead I will be using a user data script. So for the EC2 instance name, you can give it the web tier instance, and for the we're going to choose, for the instance type, we're going to choose T2 micro. And for the key pair, we don't have a key pair, so we're going to create a new key pair. I'm going to name it my key pair, and for the key pair type, RSA and .pem. We won't be needing it as much because we are not SSHing into anything. We are going to edit the network setting, and I'm going to choose my VPC that we created. For the subnet, we have to make sure the subnet is a private subnet, as we don't want our instance in the public, and that is why we have our application load balancer. So we are going to select our security group. For now, we don't have any security group, so the next thing to do is to create the security group we'll be using for everything during this project. So we're going to be creating 3 new security groups, which is for our application load balancer, our web tier, and the database instance. The first one to create is the application load balancer security group, which allows HTTP traffic from anywhere over the internet. So allows HTTP traffic from anywhere, and the VPC, we are going to edit the inbound rule HTTP to anywhere IPv4 over the internet. Then we'll go ahead and create the security group. Since we have our application load balancer security group created, first let's rename it. Then we can filter by VPC ID, so we can see the security groups we have for this particular VPC. The next thing is to create another security group, this time around for the web tier. So we are going to name it the web tier security group, which allows HTTP traffic only from the application load balancer, the ALB. So allows HTTP traffic only from the application load balancer. Then we select our VPC and add inbound rule HTTP to, this time around, custom to the security group, the application load balancer security group, ALB security group. So with that being done, we create this security group, and then we move ahead and create the last security group. So as you can see, it is leading back to the ALB security group. So we're going to edit this and name it the web tier security group. Since we have that created, we're going to create the last security group we need, which is the database security group, and edit the inbound rule. Type is MySQL/Aurora to the web tier security group, and we're going to create that. As you can see, when we click on the source, it takes us back to the web tier security group. So these are our security groups. You can edit this and say the database security group. So we go back to creating our instance, and we're going to refresh this so we can have and we're going to use our web tier security group. Instead of creating or manually installing software, I'm going to utilize a user data script to automate the provision of the LAMP stack and WordPress. So we are just going to go to the advanced details and scroll down till we see the user data. I have one already. I'm just going to copy and paste it all here. Then we are going to launch our instance now. What that user data script does is that it automates everything. As soon as the server boots, the script updates the OS, it installs the LAMP stack, the Apache, MySQL, and PHP. It also downloads and configures WordPress, which is what we are going to be using for this project. I have attached the user script in the description, so in case you need to use it when setting up your project, so you can just go ahead and check it out in the description below, just below this video. And since we have our EC2 instance created now, let's we'll click on this and check what is going on. The EC2 instance doesn't have a public IPv4 address because we are going to be using the load balancer DNS name. So that is why the next one we are going to create is the load balancer. The load balancer serves as a single point of contact for clients. The load balancer distributes incoming application traffic across multiple targets. So I am going to deploy an internet-facing application load balancer now in the public subnet and attach application load balancer security group. So for the name, we are going to name it the My Enterprise Application Load Balancer ALB, and it's going to be internet facing. For the networking is going to be our VPC. The application load balancer, it has to be in at least 2 availability zones. So we are going to pick the US East 1A and 1B, and it has to be in the public subnets because remember, this is what is going to use to distribute traffic coming from the internet. So it has to be in the public subnet. Then we are going to go for the security group. Remember, we created the application load balancer security group, so we'll go ahead and select that. So we already have it. This is it, the application security group, which is the sources to the internet. So the next thing is to create a target group. We don't have a target group now, so we click on this link. A target group basically is a logical grouping of resources that load balancer forwards requests to. So it acts as a destination for specific types of traffic. So the target group name, we are going to give it My Enterprise Target Group TG. So IPv4 address, yes, and the VPC, will choose our VPC. The health check, take it from here, from the end of this script, copy, and we are going to paste it here. So with that done, we will click on next. I think everything is okay here. Then we'll click on next. So we select the EC2 instance we created as the target. So we want to register that target and we include it as pending. Include as pending below. Then we'll click on next. So since we have registered that target, the next thing is to create the target group now. And we have our target group ready for use. So we can go ahead and create the target group. Since we have our target group ready, we can go back to creating our load balancer. So we'll go back to the page where we are creating our load balancer and refresh it. Then we're going to choose the target group we just created. So and that is all. We create the load balancer. This is the summary, and we review and see everything seems to be correct. So 2 availability zones in the public subnet, and then we create our load balancer. We have the load balancer successfully created, and for now it is still provisioning. So while we wait for our load balancer to finish provisioning to be active, we can just go and start creating our database that we'll be using for the WordPress blog. We go to our RDS console now, and then we click on create a database. So we can create a database we'll be using for this project. So we are going to be using my SQL database. So we'll use the production template and a multi-easy instance deployment, so for high availability. The database instance identifier, we're going to give that WordPress DB. Then for master username admin and for credential management, we'll be managing using AWS Secrets Manager. So it will help us manage our username and password. For instance configuration, we'll change to bus table, and we'll be using the T3 micro because this is also a project that won't be using for long. So for the storage, we change it to GP2 and allocated storage to 20. For connectivity, don't connect with an EC2 instance, but instead we'll be using our VPC. And then for the subnet group, we don't have a subnet group yet, but we'll have to create a subnet group, which we are going to do now. So but before we create the subnet group, let's check our load balancer again, and now it is active. We can copy the DNS name to open our application. So Here it is, our WordPress blog. Can continue. Let's go. So now we need these details from our database. We need the database name, the username, the password, and the database endpoint, which is the database host. So we'll continue creating our database right now, and we create our subnet group first. Then I'll click on create DB subnet group. For the name, I'll give it my DB subnet group, and hopefully I don't have any subnet group pairing with the name already. For description, my subnet group, and the VPC, we choose our VPC. For availability zone, it has to be in private subnet. So private subnet 1 and private subnet 2, which are in two different availability zone, US is 1A and 1B. So we'll click on create. We'll create now. So we already have a name. We have a subnet group with that name already, so I'm going to go ahead and change to just DB subnet group and create. So now that we have our subnet group ready, the first one, DB subnet group, is the name of our subnet groups. So we can go back to creating our database, and we just need to refresh our VPC, and now you see our subnet group appears. It shows right now. So public access, no, we don't want public access to our database. For the security group, remember we already created our DB security group, so that is what we are going to be using, our DB security group. So what else is there to check? For additional information, we leave it as it is. For database, we leave it as it is. We leave everything else as it is. Okay, we would enable that. Then for the initial database name, we'll give it test DB, and we'll enable deletion protection. So we can go ahead and check everything again. MySQL, multi-AZ, yes, correct. WordPress, AWS, yes, bus table. Okay, everything seems okay, and then everything seems fine. We can create the database, and we are going to wait for, it takes about 2 to 5 minutes to provision this database. And while we wait for our database to get created, we can go into our AWS Secrets Manager to check for our username and our password. So search for Secrets Manager and open that, and as we can see, we have a secret already created in our Secrets Manager, so, and it is associated with our WordPress DB. So we'll go ahead and click on that. Then we scroll down and click on retrieve secret value to get our username and our password. So now that we have our username and our password, we can go back to the application, the WordPress. Now we have the username and we have the password, and we also have the database name. So, but we need the database. We'll still be needing the database host, which is the database endpoint. So we'll have to wait for our database to get created to get our database endpoint. We are going to refresh, and now our database is available. We can use the endpoint from the database in our application. For database name is testdb, username is admin, and for the password, we go back to our Secrets Manager and copy the password and paste it. And for the database host, we use our database endpoint and we paste it, then click on submit. And then we are in our welcome page where we give our site a title. I am just going to say my blog site, username Ismail Oyeleke, and email. I have a temporary email created which I am going to use, and then we will install WordPress. Then you only need to log in, and after you log in, you would be in your WordPress dashboard or your WordPress homepage, and that is it. The last thing we need to do now is create an auto-scaling group. So what auto-scaling does is that it automatically adjusts the number of computing resources, in this case the EC2 instances, to match application demand, ensuring high performance and availability while optimizing costs by adding capacity during spikes and reducing it during low usage. So it prevents over provisioning, and it also helps in ensuring you only pay for what you need and what you use. So without further ado, we're going to go and create our auto scaling group now. The first thing we need to do is to go to our instance and create an image from that instance so we can use it for our launch template for the auto scaling group. So we create image from this instance that we have already. We create an image and then we name the image. We can name the image WordPress image. So for the description, we'll leave it as it is optional, and then we just create the image. So, and after creating the image, we can check it out on the AMIs. So it is available now. It is still pending. It will be pending for some time. So it is pending, and while it is still creating, we would go and launch it. Our template, we'll create a launch template. So we'll use that AMI to create a launch template. So we are going to name our launch template. We can name it WordPress launch template. WordPress LT launch template. So with that being done, the next thing is to choose the AMI we need. So since we created an AMI, we are going to choose the AMI we created some few seconds ago. So WordPress image, we choose that, and for the instance we are going to choose T2 micro. Then we create or we choose our key pair, which we already have my key pair, and we choose our security group. We are going to be using our web tier security group since we are using it for our instances. So, and after that, there's nothing else to do. We should create launch template. So we click on create launch template and view the launch template. It is available now and ready to use. So we'll go back to our auto scaling group and create auto scaling group. For the name, we are going to say WordPress auto scaling group. That's ASG. So for the launch template, we are going to use the word launch template that we have before. So this is it, and then we are going to click on next. The next thing is our network section. For the network, we are going to use our VPC. For availability zones and subnet, it has to be in the private subnet in both availability zone. So we are going to choose private subnet 1 and private subnet 2 because it is for our instance, and our instance should not be made public. So with that being said, we are going to choose that, and then we are going to click on next. For the load balancing, we will attach an existing load balancer, and then we'll add our target group. So we will click on next. For the desired capacity, we are going to use 2 for our desired capacity, so it launches 2 instances immediately. So we use 2 for our desired capacity, and our minimum capacity is also going to be 2, and the maximum capacity we use 4 as the maximum capacity. For the automatic scaling, we are going to use target tracking scaling policy. So we are going to use our average CPU utilization, and the target value is going to be 50. What this means is that the auto scaling group maintain the desired capacity of 2 instances, scaling up if the CPU utilization exceeds 50%. So we are going to click on next, and then go to the review section, and then we review everything: the availability zones, load balancer, scaling, and then we're going to create the auto scaling group. And now that we have our auto scaling group ready, we are going to check what is going on in the. So we have to click on instance management, and as we can see, we have 2 instances spinned already because our desired capacity is 2. So we go to our instances to confirm if we have 2 extra instances, and we're going to refresh, and as we should see 2 new instances initializing or ready to be created. So we're going to wait for this to get refreshed, and as we can see now, we have 3 instances and 2 are initializing, which means our auto scaling group is working properly. Another thing to check is our target group. So we can go ahead to check. Okay, they are in service now. We can go ahead to check our target group. So if we refresh this, we should have 3 target groups now: the initial instance we created and the new 2 instances the auto scaling group have created. So, and they are all LD. So now we have 3 instances. So we go back to our instance, and let's try to terminate one of the instance and see if the auto scaling group is going to spin another EC2 instance, because it has to always have 2 instances running, because we set the desired capacity to 2. So we just terminated one of it. We're terminating one of the instance, and we'll go to our target group and refresh it and see what's going to happen. So now we only have 2, because one of them is being shut down, is being terminated. And when we go back to our auto scaling group, we'll see what happens there. So we see that we have 3 now. One is on LD, that's the one we terminated, and auto scaling group automatically spins another EC2 instance, because the desired capacity is 2 instances. So we are going to refresh this again in our instances, and now we should have 4 instances, 1 terminated and 3 running, one of them being the first instance we created. And that is it. We have now moved from a fragile single server to a robust self-healing 3-tier architecture that uses enterprise security standards. And if you want to try this project yourself, I have uploaded the full documentation, architecture diagrams and scripts to my GitHub. So the links are in the description below. If you found this helpful, hit that like button and subscribe for more cloud engineering projects. I am Ismail Oyeleke, and I will see you in the next cloud projects.